Myself K. Vijay Kumar. I am from Mechanical. Today I am explaining about index organizations for object-oriented database system. Introduction to index organizations for object-oriented database systems. Index organizations are essential for efficient data retrieval in object-oriented database systems. They provide a way to locate specific objects based on their attributes or relations. Different index organizations of varying performance characteristics suitability for different types of queries. Object oriented database management system. An object database system is management of which information is represented in the form of objects as used in object oriented programming. Object oriented database store data together with the appropriate methods for accessing its encapsulation. Object oriented database combine the object oriented feature database capabilities. It allows a more direct representation and modeling of real world problems. B-tree index organization. B-tree is a commonly used index organization for object-oriented database systems. It is efficient for both range and equality queries. B-tree maintains a balanced tree structure to achieve logarithm search time. B-tree example. Hash index organizations. Hash index organizations is suitable for equality queries on attributes with a high degree of uniqueness. It uses a hash function to map attributes values to enter index entires. Hash index offers constant time search complexity but are not suitable for range requires table date. Column volume hash function hash bucket 1 hash bucket 2 hash bucket 3 hash bucket 9 hash bucket 1 hash bucket nth. Bitmap index organizations. Bitmap index organizations is useful for querying on boolean or categorical categorical attributes. It creates a bitmap for each attribute value, indicating the presence or absence of that value in each object. Bitmap index are compact and allow fast bitwise operations for query processing. Encoded bitmap index consists of a set of bitmap vectors, a lookup table, a set of each distant value of a column is encoded using a number of bits, each of which is stored in bitmap vector. Lookup table stores mapping between columns values and their encoded representation. Properties of bitmap index. User space efficiently with wide range queries. Difficult to find a good encoding scheme. If inefficient with equality queries. Artery index organizations. Artery is an index structure suitable for spatial data in object-oriented database systems. It represents spatial objects as rectangles and organizes them in a tree-like structures. RT enables efficient spatial queries such as range search and nearest neighbor search. And R1 and R2 and R3 and R level are the examples of R-tree index organizations. And now we are talking about quadtree index organizations. Quadtree index organizations is another special index structure for. This is about R-tree index organizations. Now quadtree index organization. Quadtree index organizations is spatial index. It risky divide space into quadrants, allowing efficient spatial indexing. Quadtree supports spatial range and requires a nearest neighbor search. Primary index. A primary index is based upon primary key of objects in the database. It provides a unique identifier for each object and facilitates direct access. Primary index are typically implemented using B-tree or hash index organizations. There is an example primary key and Fergin key. This is now about primary index. Secondary index. Secondary index are based on non-key attributes of objects. They allow efficient access to objects based on their attributes. Secondary index are often implemented using B-tree or bitmap index organizations. Secondary index condition. A dense secondary index with block pointers on a non-ordering key field on a file. This is about secondary index. And now we are talking about multi-level indexing. Multi-level indexing is used to handle large database with limited memory resources. It organizes indexes initially with each level representing a subset of data. Multi-level indexing reduces memory requirements and improve query performance. Multi-level indexing reduce memory requirements and improve query performance. Outer index, inner index, data blocks. Here it is a multi-level indexing. When we are talking about index maintenance, indexes need to maintenance to reflect changes in the database. Insertions, deletions, and updates on objects require corresponding index updates. Efficient index maintenance techniques are crucial for maintaining query performance. Index maintenance is need to be maintained to reflect changes in the database of the insertions, deletions, updates on objects. Efficient index maintenance techniques are crucial for maintaining query performance. Index selections. The selection of appropriate index organizations depends upon the characteristics of the database and query workload. Factors to consider include data distribution, query patterns, and resource consistency. Performance evaluation and benchmarking can help in selecting the most suitable index organizations. Issues in index selections condition. Multi-attribute search keys should be considered when a where clause contains several conditions. If range selections are involved, order of attributes should be carefully chosen to match the range ordering. When consider a join condition, hash index on inner is very good for index nested loops. Should be clustered if join column is not key for inner and inner tuples need to be retrieved. Clustered B plus tree one join column is good for short merge. Conclusion. Here it is the conclusion. Object oriented database. Graphical user interface, powerful modeling techniques, advanced data management capabilities. The index organizations play a vital role in optimizing data retrieval in object-oriented database systems. Various index organizations such as B-tree, hash, bitmap, and R-tree and quadtree offer different capabilities. Careful considerations of index selections and efficient maintenance are essential for optimal performance. Object-oriented database synthesis double systems associated with graphical user interface GUI for powerful modeling techniques, advanced data management capabilities. What effect will double concepts have in DB data science design? What about the extend relation system? Thank you. Thank you.